Hello, welcome to this unit in Algebra 1. Here we're going to spend many lessons talking about the concept of quadratic equations in algebra. So we've spent a lot of time solving equations, linear equations, which are lines, which are all the equations that we've been talking about up till now. Here we're going to talk a lot about quadratic equations. So the easiest way to do this is to kind of start with an example, and I want to do a few definitions along the way, but then we're going to get into cranking through a bunch of these topics as we go along here, step by step. So the first equation that we're going to solve, just as the first introduction to the whole thing, is 3x squared is equal to 108. All right, so this is a quadratic equation, and you're going to become very good at identifying when an equation is quadratic and also what the concept of a perfect square is, because the type of quadratic equations that we're going to solve here are just ones that involve perfect squares. So let's go off to the side here and do a few definitions. First, there's this idea of a quadratic. Quadratic? Okay, so when an equation is quadratic, it just means that it has an x squared term, right? So whenever you think about that a little more carefully, all the equations that we've really spent a lot of time dealing with have all been linear equations. They've all been equations of lines. In other words, when an equation does not have the square term here, like 3x plus 4 equals -5 plus x or something like this, all of those terms just involve x. Those are called linear equations or equations of a line. Here, when you have square terms, we call them quadratic, and they require different methods to be able to solve them. And so anytime it has an x squared term, that's what we call it. Now I want to spend a minute to identify what the concept of this perfect square is real quick before we do a bunch of problems. So a perfect square, it sounds amazing, right? It's a perfect square. All it means is that the equation that you're talking about can be written as, or in the following way, which is square term is equal to k, where this is just a number. Now, I know I'm jumping out of here really early on, and you might be thinking, well, what's he talking about? This is a bunch of definitions. I don't like this. I just want to present these two early on because as we do these problems, I want to point out to you why they are quadratic. Okay, for the first part of this is this equation, the first problem that we're going to solve, is called quadratic. And the only reason that it is just because it has an x squared term. That's all you have to look at. Right? Now, the second part, the fact that it's a perfect square, or that it can, this equation can be written in terms of this, we need to do a little bit of work here. So if you were to solve this, how do you think you would proceed? Well, obviously, when you solve any kind of equation, you want to get x by itself. So obviously, this is not x. This is x squared. We'll deal with that later. But initially, we also have this 3. We don't want that 3 there. So the first thing we're going to do is we're going to rewrite the equation. 3x squared is equal to 108. And we're going to divide both sides by 3. Because we already know that that's going to cancel the 3's on the left. And all you're going to be left with on the left-hand side of the equation is 108 divided by 3. And if you do that math, what you're going to get is 36. So you see, initially, we start the equation like this. But just by one single step, we can get the equation into this form, which is x squared is equal to a number. Now look at this. A perfect square, a perfect quadratic square, is when you have a square term, which is what we have, a square term, equal to, we call it